Hi everyone, this video will walk you through the use of the comparison test to determine the convergence or divergence of a series. Many textbooks refer to this as the direct comparison test. So let's take a look at what the test tells us. We need to have two series. We're going to call them one given by the summation as k goes 1 to infinity of a sub k, and another that goes 1 to infinity of b sub k, where each series contains only non-negative terms. Suppose also for all values of k after a certain point, we know that the terms of one series are always less than or equal to the terms of the other series. What the comparison test tells us is if the larger series is known to converge, then the smaller series is also going to converge. Likewise, if the smaller series is known to diverge, then the larger series automatically will also diverge. Your textbook has a great proof of why this is true. So I recommend you take a look at that. We're going to work through two problems that will walk you through the use of the comparison test to determine the convergence or divergence of a series. The first one we're going to look at is the summation as n goes 1 to infinity of 1 over 2 plus 3 to the n. So the first thing you have to do with the comparison test is to come up with the series that you want to compare to. So in selecting your series, you want to think of one that you know to converge or diverge and look somewhat similar to the one that you're working with. So maybe one that comes to mind for this that we can compare to is the summation as n goes 1 to infinity of 1 over 3 to the n. If you think about this, this can be rewritten as 1 over 3, the quantity to the n, thereby making it a geometric series with r equal to 1/3, which of course is less than 1. So we know that that geometric series is going to converge. So now we have the series we want to compare to, and we know it converges. So the next thing we want to do is compare the terms of this geometric series that we know to converge with the given series. So the way in which you do this is you can just think about it, and maybe you know which one's going to be larger and which is going to be smaller. If you're not sure, substitute in different values of n, the same n into each series. Remember, for this particular one, the smallest n you can use is 1, and just see which one always comes out being larger, which one is always smaller. So if you try that, you should find that 1 over 2 plus 3 to the n is always less than or equal to 1 over 3 to the n. Again, if you're not sure, just start substituting in different n values, and you'll see that this is true. So think about where we are now with the comparison test. We have just shown that 1 over 3 to the n, that's the larger series, and we know that series to converge because it's a geometric series. So according to the comparison test, since that larger series converges, the smaller series is also going to converge. Therefore, we can conclude that the summation as n goes 1 to infinity of 1 over 2 plus 3 to the n is going to converge. So if you take a look at how we walk through this, this is exactly how you're going to do the homework problems. You're going to first figure out the series you want to use for comparison. You're going to state whether that series converges or diverges and why. And then you're going to do the term-by-term comparison and come to your conclusion from that. That's how every problem is going to be worked through. So let's try a different one. Now we're going to consider the summation as n goes 1 to infinity of 1 over 2 plus square root of n. So the first thing you want to do is try to figure out the series you want to use for comparison, and it needs to be one that you know to either converge or diverge. So maybe one that comes to mind is the summation as n goes 1 to infinity of 1 over square root of n. That, of course, is a p-series with p equal to 1/2. And if you think about our p-series rules, since p is less than 1, we know this particular p-series is going to diverge. So now we want to do that comparison of the one we're working with this p-series that we know to diverge. So again, if you're not sure which one's always going to be larger, which one's smaller, start substituting in different n values. Again, starting with n equals 1 in this case. When you do that, you should find it true that 1 over 2 plus square root of n is always less than or equal to 1 over n. Now this is where we have a problem. According to the comparison test, the larger series would have to converge in order to come to a conclusion. In this case, we know it to diverge. So we really can't determine anything at this point, and we need to go another route and come up with a different series that we can use for comparison. So 1 over square root of n didn't work. So let's try to think of something else that might. So maybe we'll try to compare to the summation as n goes 1 to infinity of 1 over n. This, of course, is the harmonic series, which we know to diverge. And we're going to compare this harmonic series that we know to diverge with the given series. Again, you want to substitute in different values of n to figure out which is the larger, which is the smaller. So when you do that, hopefully you find that 1 over n is always less than or equal to 1 over 2 plus square root of n. Now this works out because now we've shown that the smaller of the two series, which is the one we know to diverge, so therefore the larger series, according to the comparison test, is also going to diverge. And therefore we can come to the conclusion that our summation as n goes 1 to infinity of 1 over 2 plus square root of n is going to diverge. So moral of the story, everyone, is that you really have to know your basic series, your geometric series, your p series, your harmonic series, because they're the ones that you easily know converge or diverge, and you'll be able to use those for comparison. So if you work through your homework problems just as we did these, I think you'll find a good bit of success.